Alright, next chapter. Emergency power. Chapter 15. It says objectives. Identify the equipment to be supplied by emergency power and standby power. Explain the operation of an automatic transfer switch. Describe the various sources of emergency power. Compare optional standby systems, legally required standby systems. So this is an automatic transfer switch, and it has a switch. You can see it has wires coming in the bottom here, and it's got a set in the front, it's got another set in the back, and here's my neutrals. So one may be my normal power in, the other one would be my power out. Okay, down here at the bottom, here's another set of wires. So see, I've got three coming in, and these wires look a little bit smaller down at the bottom, so these might be coming from the generator. So right now the power may be coming in, let's say the ones in the back, and it goes, as this is in the on position here, power comes in, goes to the transfer switch, and it goes to these wires. Okay, in case of emergency, here's the solenoid, the armature, so it gets it, it pulls it down. As it pulls this down, it disconnects the back and connects the bottom wires. Okay, so that way, this is an automatic, so it'll do it automatically as soon as it senses no current. Okay, emergency power. Excuse me. Emergency power is needed in applications where a loss of power could result in hazardous to life, property, and production. Okay, so power loss creates a hazard to life, property, and production. Okay, what is it to life? People on life support in the hospital. Property. Okay, say certain things are going, and power has to stay on for certain things. Okay, so protects property. The other thing is people. If power goes down, you don't want to create a hazard because all of a sudden it gets dark and nobody can see. You know, how many of you have been stuck in a dark room or an elevator that gets stuck? You know, you start to panic because you don't know what to do. So that's what this does, is it helps so you don't have a hazard from people freaking out. So at least some of the lights come on now. Okay, you know, I think it's time to get out of this building. This chapter will address the requirements provided by the code as well as the methods of installing emergency power supply components. Okay, so we have backup systems, prevent hazards. Production, what's another production? You got a production plant. Guess what? You're in business to make money. You know, if those machines aren't running, you're not making money. So if power goes down, you know, they want to make sure that production continues even after a power outage. I had a restaurant call me up, and they said, we want to put in a generator. And I said, for what? And they said, well, if power goes down. I asked them, I said, you know, so you can keep the refrigerators going? Or, you know, keep certain lights and stuff going? He goes, oh, no. You know, we want a generator so we can stay in business at 100%. I said, all right. So I went over there and I said, okay, I'm going to come in one afternoon. So I got there, the class starts at 5:15, so I got to the restaurant at about 4 o'clock in the afternoon because I was on the way to school. And I went and took the thing and I started taking amp readings. And I asked the guy, and I said, when is your busiest time? He goes, right now. You know, and I got there and it was kind of warm, so the air conditioner was running. So I took loads. It was a 400 amp service. They had 300 amps. They were using 300 of the 400 amps available from the service, single phase. I sat back and I started to calculation. I said, man, it's going to be a big generator. I said, we're going to have to put it out there in the parking lot. We're going to have to dig across the street. He goes, oh, no, I want it right next to here. And I said, hey, guess what? It ain't going to work. You put it right next to here, forget it. Ain't nobody going to be here. You can run generator. Ain't nobody ever going to do anything because it's damn so loud. He thought it was going to be a small generator you can put in, and he can run his business. It's not the way it works. The standby powers are also presented. These systems are important for use with computers, complex communication systems, data processing networks, and the following are a brief description of the different types of backup systems defined by the code. Okay, so the different systems defined by the code is your emergency systems. An emergency system, systems where interruption of power could create health or life hazards. These systems are also included in lighting to reduce panic and aid in exiting the building. As an emergency transfer load to emergency power source is automatic. Okay. Then we have legal required standby systems. Article 701. This is Article 700. Article 701. Those systems required and so classed as legally required standby by municipal, state, and federal or other codes, or by any government agency having jurisdiction. These systems are intended to provide automatic supply power to selected loads other than those classed as emergency systems in the event of a failure in normal source. And the last one is an optional standby system. Those systems intend to supply power to the public or private facilities or property where life and safety does not depend on the performance of the system. Optional standby systems are intended to supply on-site generated power for selected loads, either automatic or manual. Automatic or manual. You know, when I worked at the hospital, we had generators. The generators have to be tested. So we'd have to come in bi-weekly and do generator tests to make sure that they were working. We have to exercise transfers. Our transfers were automatic. I'm sorry, wrong way. Our transfers were automatic. So we'd go over to the transfer. It has a board on the bottom. We put it on test. Once we put it in the test position, because it has like a computer inside, hit the button, it would go and it turned the generator on. And it had like a 30-second delay, a minute delay, whatever it was. So it had a delay when we had it on the test. It turned the generator on. Generator comes up, it runs up, gets a full speed, and then we'll transfer over. Okay, so it would transfer all power, emergency power. We would always have to let everybody know a week ahead of time, and then let them know 24 hours before we did the test. Why? So you can turn the computers off. You know, if they're working on something, the last thing you want is someone to be working on something and get up and walk away from the computer, and that quick off and on from normal power to emergency power, any information they have in the computer can get lost. So we did it as a precaution so people can turn things off. If things were sensitive to power going out, we tell them ahead of time so they can turn things off. Okay, it's all part of the test. So we go in there, we test it and let it run. We let it run for about 15 minutes. We go around. If there was multiple, like we had one generator and it had 3 ATSs. So I walk over to the first one, turn generator on, transfer that one over, go to the second transfer switch, ATS, and that's automatic transfer switch. Click that one into test mode, then go to the third one, hit it on test mode, come back around to the first one, transfer it back to normal power, go to the second one and the third one, and then once I did the last one, once the loads were removed off emergency power, it will set a signal to the generator, and then the generator would idle down and shut itself off. It ran for about 15 minutes after we turned it off because they were all turbo engines, so they had to idle down. A lot of times these generators have a heat sink inside of them to keep them warm, so they're keeping them at about 180 degrees, so they're already hot. Again, illegally required. That's where the government says you need to have a generator. Hospitals, the other generating systems. So the emergency systems in the hospital, you had emergency systems. Okay, and optional is when you can put one. You know, you got to store it, like it's telling you the restaurant. The restaurant, he wants to stay in business. That's an optional. A house, it's an optional. You know, I have a 7.5 kV a 7.2 kVA transformer, and it has what is it, about 9,500 output, max output. So in case something comes on when the motor peaks out, it can allow that, and we'll talk about that later. But these are all optional. Talk about automatic and manual. So here's an automatic system. Here's our telephone pole, comes in to our meter. Our meter goes over to the transfer switch. So my normal power would be these two. My generator power are the two in red over here, those two red circles. And my normal power are these two down here. Okay, so if I lose this, I have a sensor that's reading the current on running through those wires. If it senses that there is no current, and then it will transfer automatically. Okay, the only thing is with this is if I got a 400 amp, if this is say a 200 amp or 400 amp panel, you have to size that accordingly to whatever your load is. So if this generator has to carry full load current of everything applied, then it has to be sized accordingly as you're doing the service. So if I got a 400 amp service, guess what? My transfer switch is going to have to be a 400 amp transfer switch. If I have a 200 amp service, my transfer switch would have to be a 200 amp. On the other hand, is you have a manual. Here it comes off the utility. I didn't write it down over here, but here's my meter. It goes to the main breaker. In the main breaker, these are all the panels. So this one in red over here, that's what I designed. That's what I designed to have an emergency. So I got 8 circuits that would be on the generator. So my generator's tied over here. Power goes out. I go turn my generator on. As I turn this breaker to on, from turn this one off, it turns this one on. So there's a little bar in the middle. So both of them you can't turn on. Only one can be on at a given time. Okay, and it goes out. The last thing you want to do is I've seen people when they go in there, power goes out, and they get a generator, and then they get a suicide cord. What's a suicide cord? A suicide cord is the one that has a male on both ends. So they plug it into the generator, they turn the generator on, plug it into the generator, they go inside the house and they plug it into the house. Now they got that one circuit is all on. Okay, well sometimes I've heard of instances where people forget to turn the breaker off, or forget to turn the main breaker off. And all of a sudden power comes back on, generator's still running, they blow the generator up. They blow the transfer switch. The one that I heard about was somebody that worked for the utility companies, and they hooked it up 240 volts. They had a big generator I got. I have a manual transfer. I got one of these, and I got 5 circuits moved across. Well, what happened was the generator is like a 9,000, 10,000 watt generator, and when the power came back on, you had two sources coming into the same panel. The thing blew up. It blew the transformer up, and this is where the person that I heard it from was a guy that was responded to that call on the transformer, and he was telling me that they burned the generator, and they suspect that the transformer was also burned. It was also damaged. So they decided to change the transformer out, and then they charged the homeowner for all the work because he had an illegal transformer. Mine is a generator. I got to wheel it out of the garage, drop my cord down, plug one in, plug it in, turn the generator on, walk over and turn it on manually. Okay, that works great if the power's on for a long time. Okay, this gives me time. It gives me at least 10 minutes, 5 to 10 minutes, in case the power comes back on before I plug anything in. But again, when I turn this breaker off and it turns on, you can't do anything about it. Only one breaker can be on at a given time. Okay, emergency power systems. So what gets powered up? So you have emergency lighting. What is emergency lighting? It's so people can exit the building. You don't want to create a panic, and you want people to get out of the building. You know. Fire pumps. Why are fire pumps important? Well, if power goes down and there's a fire, well, what's going to get the water up to the 50th floor, or 3rd floor, or 4th floor? Guess what? It might not be enough pressure. in the water system to get the water up that high. So there's fire pumps, and the pumps are there especially on an emergency in case there is a fire, power goes down, at least you can still get the water going in. Ventilation is always important to have an emergency system. Again, there's a fire, power's turned off. Guess what? Fire department. When the fire department shows up, I was talking to some firemen and about solar. They called me in and I went to one of the fire departments and they were asking questions about solar because somebody experienced shock on a fire that they were putting out when they were doing whatever, they were making the vent holes. Well, anyway, I went in there and I asked them, and I said, well, when you all go into a house, you know, what do y'all do? Do y'all leave the electricity on, leave the gas on? He goes, no. He says, we have one person assigned, and his job is to go walk around, turn off all the disconnects, and the main breaker. You know, if it doesn't have a disconnect, open the panel up and pull the main disconnect. Turn the power off, same thing with the gas. You know, last thing you want to do is be throwing water on a house with electricity. Because guess what? Electricity will travel through that water. And that's what happened in this instance. They said that the gear that they wear is all leather, and leather's not waterproof, so obviously their shoes were wet, and they're standing on the ground throwing water, and one of them, when they were making the vent holes, I guess they hooked something up in the attic. They got hooked up, he hooked up to the DC side of the inverter, the solar panels on the roof, and he got shocked. Okay, this is before this one was done. He says they hooked up a piece of Romex. So they ran the Romex down to the inverter, and they ran Romex and inverter, and the code says use the steel raceway. So I don't know if it was done before codes were changed, because I never went back to find out. But anyway, guy got shocked. Now we have codes, so we don't have that. So we can turn power off in between the inverter and the solar panels. I went somewhere else, but other systems that prevent hazards. So again, anything that helps people get out of the building. Ventilation, where do you want the ventilation? Well, sometimes as the fans come on, and they may have a relay that the fans turn in reverse. So in case it goes into an alarm, the fans start blowing, start sucking, and they start running reverse. So we talked about motors, and we're talking about reversing relays. All of a sudden, one relay shuts off, the other one turns on, now the fan works in reverse. What does it do? It helps get the smoke out of the building. So it aids the fire department trying to get the smoke out of the building. That's why fire department makes holes on the roof, and they go inside and they make holes in the drywall to let the smoke out. And also gives them another option to throw water into the building. Automatic transfer equipment. Hold on, let me get back to the book here. It says that when a standard service fails, emergency loads will be automatically transferred to the emergency power systems within 10 seconds. This is accomplished by the automatic transfer switch. Look over here. The automatic transfer switch contains a voltage sensor that monitors the standard service conductors. When the standard power source is supplied little or no voltage, the automatic transfer switch signals the generator supplying the emergency power. So this would transfer over. So it's some read current, sometimes they read current and voltage. This is always good because in case you have too low a voltage, this would also This would also transfer in to allow the generator to come on. Once the output, it says the generator supply the emergency power, the generator starts, the transfer switch monitors generator output. Once the output reaches the acceptable voltage and frequency, the transfer switch disconnects the emergency loads from the normal power and connects them to the emergency power. Okay, so again, it's also monitoring the voltage from the generator. So make sure the voltage is at a certain point. A lot of them, that's why they have heat sinks within the generator, if it's a diesel generator or gas generator. So they keep it at a certain temperature. Guess what? The engine does not have to heat up quite because it's already hot. They got it, running speed may be 220 degrees, so they keep it at 180. so it doesn't take much to heat up, but it can still transfer over instantly. UCLA, then things transfer over within 6 seconds. Yeah, hospital. You don't want people to be down too much. People start freaking out. Let's see if they got the note on here. No, they don't. This says, note, an audible and visual signal device indicates when loads are being supplied by the emergency power source. So, when you're at the transfer switch, it has a front of it, and it gives you a design. It gives you what it's doing. It also tells you what the voltage is. The ones we have, they have the voltage. The power output, you can always find that also on the generator itself. So depending on where everything's at. You know, if you got one generator and one transfer switch, and it's easy, why it's all going to be located centrally. But when you have a big building, and they may have multiples, why? Because let's say I got a volt on the first floor, and the first floor takes care of the first, second, and third. And then I have another one on the third floor, or on the fourth floor. You know, it takes care of 4, 5, and 6. And then I have a separate one that does the motor separate, because the motors are separated from my power and my lighting. Okay, so now I got 3 transfer switch run by 1 generator. Okay, so now you have to check all of them to make sure everything's running. So sometimes you may have at the generator would have, you can walk up to the generator, it tells you the voltage output and how many amps it's producing, what it's producing, and what it's being used. Because it gives you an output and an input. Oops, backwards. Alright, emergency power source. This one's talking about. So the emergency power source. Sources of emergency power are discussed in Part 4 of Article 700. Part 3 of Article 700. There are several ways in which emergency power can be supplied. So you have storage batteries. When you have storage batteries, they've got to supply 87.5% of normal voltage for 1.5 hours. And we'll get into sizing and all of this. I'll send it as a separate. Generators. So engine type or generator capacity. Okay, so an engine type, gas, diesel, propane, natural gas, minus propane. You want to have at home is propane. Got big tanks on it, big tanks, and engine capacity. So, and then you have a separate service. So we have a service here. So what we can do is we can have a separate service, and it can go through a transfer. So in case this service goes down, but the other service, let's say my problem, if I have a separate service, so I have 2 services coming in. One is on normal, one is I would consider my normal service, and the other one is my emergency service that I can transfer over. But the only problem with that is if the service goes down, if the power lines go down, guess what? You're out on both of them. Both services would be off. That's only good in case you lose power on one, you can also transfer to the other. So let's say the main breaker goes bad, and you don't have a 400 amp main breaker. Or the time it's going to take, say it's a disconnect, the time it takes to change it out, because it's not the fuses, it's a disconnect. So you have a separate service that you can transfer over, turn power over to the other side. Now you can work on the other one. That allows you. And then it says supply tap ahead of the main. So what they're talking about is I have my power coming here, but I also have a separate one. So my emergency, let me use these blue here. So basically is I don't have a generator.
I could not find the answer to your question.
And I come from here to here and here to here. Okay?
I could not find the answer to your question.
So what happens is, let's say I have a problem here, I can always tap it here and it moves it over. Again, if I lose a utility, doesn't matter where power comes from. If this is down, you're down unless you have a generator. Supply type, and this is individual unit equipment. What is individual unit equipment? So those would be like the emergency lights people put out in the hallway that are battery packed, so it just turns on. So it's an individual unit. Or you may have a UPS that turns on certain things. So you have different times. When you're sizing the generator, and this is one of the things that I'm assignments, this book, this one does not get into that. We talked about that in Electrician 1 and in Electrician 2, and it's covered more on Electrician 4. But I'm going to get into it. I'll send you assignments. Your assignment will be on sizing either a battery or a battery, or sizing the generator. What wire size? What, you know, we have a specific load that we have to keep. What size generator we need? What size wire we need to run that? Okay. So there's the separate service, supply tap ahead of the main, and individual unit equipment with individual batteries. So again, so you have a piece of machine that can run either on electrical or battery. So it's always charged, power goes down, the machine continue to run. Or emergency lights in the hallway, emergency lights in the hallway or in the stairwell. Okay, power goes out, those come on. Okay, I'll get one out, I have one outside, and I'll bring it in and I'll show it on my next video. So I'm going to leave it here, and then this is going to be for night. I'm going to send a couple other videos tomorrow, and then we'll start working on these, alright? Y'all have a good one.